here. So okay. 91, 50. No, what is it? 51?
Yes.
51. Any others from 91? We're gonna get to that one quick, and then 92. 51. Says write the first 5 terms of the sequence, define recursively. So this is a recursive sequence, guys, real quickly here.
Oh yeah.
Good. Guys in the back, just a little lower, just a little lower. All right, okay, so A1 is 28, and the recursively, we do this right here. It is, going down. So remember, recursive functions are based upon the previous one, always. So this is the first one, and any next one is going to be 4 lower. So if you want to get to the next term, it's going to be like 2. A sub 2 would be A sub 1 minus 4. Good there. No, recursively. So we got ourselves a 28 minus 4 is 24. And then when you go to A3 is going to be 24 minus 4, which is 20. A4 would be the 20 minus, perfect. And you got 12, is that 12? Done. Da, 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 da. We find out that in nature, when a leaf, we try to do a growth of a leaf, area of a leaf, we do patterns of a leaf, right? This was an explosion in mathematics. When we started doing recursive functions, we're like, oh, wow. Meaning like we were able to model leaf growth. Explosion in math knowledge. When someone came up with like, hey, you can define patterns recursively. And we were do that, we were able to model a lot of growth in nature. Elijah. Yes, absolutely. And again, it's, yeah, a whole new field there. There's certain times in mathematics where certain things happen, you're like, whoa, and a whole new field spawns from it. In the 1600s, bless you, it was card games, and it was statistics and probability. I'm like, hey, we can do this. And
I feel like I've done solitaire in a math class before. I don't remember what it was about.
Good.
Can we do 71 for them?
71, absolutely. Any other 9.2s? 9.2. Going once, going twice.
I understood how to do this one in theory, but
Sure. Correct, yeah.
it's due Wednesday.
It's
I
due
think, with
Wednesday.
9.3.
Let's see, since we didn't finish up 9.3 lecture, then it moves on to the next one, right? So Friday. Right, we didn't finish lecture, right? For 9.3. Okay. Okay, 71. Any others from 9.2? Going once, going twice. Just 71. Well, it's jam. So we're going to do this here. We're going to figure out what is the summation from n is equal to 11. Yeah, sure. Let's do this here. So we have it here. So 9.1 is due today. What is the 25th? 9.2 would be on the 27th, since that is already finished. And 9.3, since we're going to finish today, would be on the 29th. Okay, n is equal to 1 to n, and this one is, sorry, to n. Boom. Okay. And so we go back over here. And we have this little formula, don't we? This little, it's the sum of the finite arithmetic sequences, the S formula, because it's for sum. And it has this right here. A1 up to AN. Okay, are we good with that? And just means, just like Frederick Gauss, right? He added from 1 to 100, right? You can flip it around each time. You can add the same numbers, right? Just divide by 2, right? You get 101 additions 100 times and divide by 2. So for each one of these here, so we're adding from, it's a lot of addition here. So let's go for it. So the first one, this one right here is going to be, how many n's do we have? From 11 to 30.
Wait, ends in the border.
Everybody okay with 19? So yeah, let's start counting. So 11 would be, first iteration would be 11 would be 1, right? So 1 is equal to 11, right? In a sense, right? So 2 is 12, 3 is 13, we go and so on. So that means what? 10 would be 20, is that right? Because we're exactly 10 behind, right? So then if that's the case, are we okay with 20 being 30? Yeah, it's almost like we chop off 10 pieces, right? So we're 10 behind. Cool, okay, so I got 20 here, 20 over 2. The first iteration would be 11. And the last iteration would be 30. So that's just a little first piece though. We're going to be subtracting it from 1 to 10. 10 over 2, all yours. Right, 1 plus 10, right? The first iteration would be 1, last iteration would be 10, and all yours to finish it up. 3 minus 4 times 7. All right, you guys finish it up and then tell me what you guys get. And I'm gonna jump to the back of the book to see what they got. 9.2, 71. That sounds about right. What'd you guys get?
55.
Is that right or did you do
11
something?
plus 30 equals 43?
I don't know. 41 maybe? 41, whole bunch better. Okay. 41. 355. Yep. I go 355, yeah, because the 10 being there. 45 will get you 100, so that 10 more. Okay, 9.2, 71, are we good? Sweet. So we'll go with it, the sum of geometric sequence. So again, this is something that's being multiplied together, and I don't want that. I actually want to add them all up. That's what I'm looking for, adding them all up. And so how do we get to the end? Just like the sum formula that we did on the homework just now. This is the sum formula for a geometric sequence. So start off with a sub 1, first one. And then all we do is we go and 1 minus r to the nth power divided by 1 minus r. Again, just a formula with it. Let's look at some numbers here because it'll be a little easier with them here. I need you guys to find the sum from I is equal to 1 to 12 of this little guy right here, 4 to the 0.3 I.
Yeah, and then we did it so it was the 4, then in parentheses 1 minus 0.3 squared over 1 minus 0.3. Oh, 12.
So I'm gonna go, yeah, 12th power, and then the only thing that we have to be seeing is that we do have this little I minus 1 right here to work. Okay, and that's a punch into the calculator here. So I don't think I did that one. Okay, yeah. So the only thing that we can probably do a little bit is 1 minus 0.3. We can make this into a 0.7. That's cool. So I'm going to rewrite it over here. This is the exact same thing, except now I have a 0.7 in here. And then let's punch it into the calculator. So a few things we've got to keep in mind is for this top piece, the multiplication by 4, we have to put an extra little parenthesis here for this top piece, just to keep it as one single unit here. So there it is, what I've got on the calculator here. You guys try it on your calculator to see if you guys get the same thing. Go. Those of you that have calculators. Which is 2 people. Oh, 3, okay, cool. Just for. So try it, tell me if you guys got it, and we'll jam.
So I'm just gonna round it to 5.7.
5.7, just perfect.
Like 3.27 approximately. Actually, I'm just gonna do 3.3 approximately. Because then you divide it, oh, I did it divided by 7.7.
All right, anybody else good? Look, are we good with that one? 5.7, it's cool. Yep. I put 714, but that's fine. 5.7, as long as you guys know what you guys are doing. And it looks, I'm not going to be very specific on what it is or what it isn't, as far as rounding is concerned. Okay, good to go there. Abby, you good with that one? Cool. Okay. Let's jam with this one here. Example number 6. So then use summation notation. Don't solve it, but just use that to find the sum of this little guy right here. Dot, dot, dot. All right, let's go with it here. So anybody, any thinking here on it here? Let's see, what can we do as far as, that's a summation formula, right? But I'm thinking, okay, individually though, if you look at it, 0.1, that's the first term, right? 0.4, that's the second term, third term, and so on and so forth, right? So now the question is, how do you go from 0.1 to 0.4? Or what's the multiplier from one to the other?
Times 4.
No, times
Or 4.
Yeah, just 4, huh? So you can either think about it as that, or you can just say, remember the definition of geometric forms is you take A2 divide by A1, and you should get the R value right away, right? So just take one term divided by the previous term. And that should hold. If it's a geometric sequence, that should hold. So 1.6 divided by 0.4, also 4. Guess what I know? I know my R value. I know A1 as well. I think I'm good to go there. Boom. R value is this. My little problem here is how long do I go? So 102.4. Well, he knew that he was going to do Frederick Gauss. He knew that he was going to do 100 of them, right? Because it was 0 to, or from 1 to 100, right? Here's our little problem: is that 102.4? I don't know how to get there. There's kind of 3 different ways to do it, though. Divide by 4. Let's see. Let's just try some. Don't copy me. Okay. What do you guys say? Divide by 4. What do you get?
25.6.
Okay, that just does not look right. No. Okay, Noah says take that, divide that again. Can you help us out? Back to that.
Just do 102.4.
Yeah, right here, 102.
6.2. Yeah, when you add them up, they don't all equal the same value. We'll go
6.2 divided by 4, Elka? How about that one?
us.
One more?
It's 6.4 divided by.
Oh, 6.4? 6.4.
1.6.
Gotcha. Okay, I think we got what we need out of it. So that means this is 1, that's 2, that's 3, that's 4. Is that good? And that's 5. Are we ready? Are we okay with that? Okay, let me see the way I did it, because I just want to see. Screen. No, it's going to go here. I'm going to erase all this stuff here. You could also do it by calculator. And so you know that you already have 0.1. And you know the R value is 4. So at this point, you know it is 0.1 times R to the, and that's the question mark at that point. So then let's just put in some numbers. If I put an 8 into it here. Huge number, yeah, into the 6,000s at that point. Okay, that's, I put a 6 in there, I put a 5 in there, and the 5 is the one that gets me this little piece right here. Perfect. Okay, so yes, by calculator as well, you can just keep on dividing back if you need to as well. So here's what I got. So if this is true, is that true? This guy here, if it gets me to 102.4, what I want for my formula is not an n. What I want is an n minus 1. We good?
So 0.44 is n minus 1. Have to do that.
Are we okay with n equals 6? Right, because the formula, remember the formula has to be an n minus 1 in order to match up our summation stuff. And so when we get to 5, that's great. We got to 5, but that 5 has to match up into n minus 1. So in that case, the n is a 6 value. Ooh, tricked you guys. Okay, I think we're good now. So how about A6? No, A6, just the fact that we have that piece there. Okay, can we do the sum formula now? I think we can. Let's see. Let me look at this real quickly here. So if we do this real quick here, I'm gonna go that way. How about this? So I got the sum, I is equal to 1. We're going up to 6, 0.1, 4 to the n minus, or I minus 1. Are we good there? Talk to me. Does that make sense? Convoluted. Do another one like that? Maybe. Okay, can you guys give me the sum now? I have it in the form. I'm in the wrong section. That's why it doesn't look all that great. Okay. Boom. Okay, 0.1. This 1 minus 4 to the to the 6th power. Perfect, and -3.
the 6 is 4095.
Sorry, I'll say again.
I'm sorry, 4 to the 6 is 4096, I think.
Okay, just that piece though, right? 4 to the 6 is
So 1 minus 4096.
4096 over -3. So we're getting there.
Negatives cancel each other out.
1 minus that is will be a -4095. Is that right? Divided by -3. Negatives cancel out. Let's see, multiplying that by that would be
1365.
something like that. And you guys talk to me when you get it. What's the final answer?
136.5.
136.5. Anybody second?
6.6, so.
How did you get 136.6?
Okay, let's try it. Let's take a look at it here.
0.1 is all
I got the same thing as I got.
Let me try it real quickly here as well. 0.5 or 0.6, let's see. Uh, 0.1. I'm going to go like this here. I'm going to go put it all together as 1 minus 4 to the power of 6. Close off the top, divided by a -3. Close off the bottom. There's that one.
well,
I'm just curious, where did you get the 6 from?
I don't know
Yeah, out of curiosity, like, what did you do on your calculator? How did you do the problem?
like exactly how you just did it.
Oh, really? Just kind of punched it in?
Yeah.
Maybe your calculator's
Maybe it's
just
just
messed
got-
up.
Yeah, maybe it's got.
Your calculator's just given up.
It's playing on the calculator.
Absolutely, that's what I would do. I blame it on yourself. All right, that was example what? 6. Okay, let's try another one. Very similar to this here. That was off here. So how about adding? Okay. Example 6, right?
7.
7. Okay, 32 plus. Ooh, this would be interesting. 24 plus 18 plus, and then it goes until we're at 10.125. All right. So you guys talk to me. What should we do? Think about them instead of addition. We think about them as just individual pieces, right? So I got a 32 as a first term. I got a 24 as a second term, 18 as another term, and it goes all the way down to a 10.125. Whoa, we got fractions. We didn't start off with fractions. We end up with fractions. So this is a geometric sequence. So talk to me here. What multiplication gets you from 32 to 24? Of course.
It has to be 8.
1.3.
Good job. Yeah. 1.3 repeat.
I thought it was 3/4. Because you put the value 2 over.
Cool, yeah. I'm making you guys do it the long way here, but the short way is, Elka said, we just take the second term divided by first term. Is that right?
Yeah, and then the common one is 8.
8.
So then it was 0.
3/4. Okay, and then we can even check just to make sure 18 over 24. Does that still give you this what we need here? By 6. 3 over 4. Perfect. Great. 3/4 is our value. So I think I got a few things here. A1 is a 32. My R value is 3/4, okay. And then all yours, by calculator or by hand? What do you guys say? Right, we could do it Noah's way, by hand, go backwards, right? 10.125, divide by R value, divide by R, that's how we get to 18. We could do it by calculator, which is we know this to be true. N-1, but we're just going to try. We're just going to try to put in some n values right here. Some numbers right there. And we're going to want to get a 10.125. That's our goal here.
Can't we take the 10.125 and like divide by 3/4 or something, since we multiplied something to get 3/4?
Yeah, let's do that. Actually, Elka, let's, if you want to be sophisticated, let's go with it here. We'll be sophisticated because we can actually do it by algebra. So 32 times, in parentheses, 3 divided by 4 to the power of, and guys, give me a guess. Give me a number, any number. 6. Ding, ding.
That's too high.
Yeah, it's 5.
5. Oh, bummer, it's not 5.
Yeah. 4.
32 times 3. Oh, that was sneaky. Right, because this was the first term here, right? First term, second term, third term, right? So it should have been like that. So going the other way here. I'm gonna play around with it just for a second here, guys, real quick here. If we just kept on going with 18 multiplied by 3 divided by 4. Then multiplied by 3. Ooh, there we go. Did we do this in our calculator like this right here? Once you start your calculator, especially the TI-83, you can just keep on pressing enter right now. Let's do this real quick here. You see this little answer that comes up? Whenever you press one of these buttons right here, it automatically brings up the previous answer to you guys real quick here. So if you go like this right here, if you say 32 divided, oh, so multiplied by 3 divided by 4. That would be our second term, is that right? Multiplied by 3 divided by 4. This would be our third term, and our fourth term, and our fifth term. We're good? So it just kind of keeps on going. You can, once you get the iteration correct, you can just keep on going. Did we ever do that in class with the calculator? Did we get the iteration going? Okay, that's trig then. Okay, let's do one more. Elka says there's one possible way, at least the way I understood it here. This is an algebra problem, isn't it? We're trying to figure out this. I'm trying to figure out what number up here gives me that value right there.
Well, we know that it's 5, but since n-1, so we need to be, or no, we know it's 4, so then since we know it's n-1 would be 5.
Yes, I'm just thinking over here. Can we make this into algebra problem? We're trying to figure out when 32 multiplied by 3/4 to the some kind of power here is going to give us 10.32. Divide by 32, absolutely. Do that, do that. What do we get there? What is 10.125 divided by 32?
0.3164, so then it's just rounded up to 0.32.
0.31?
21640.
I would probably, yeah, I'll probably keep as many digits as I can because we're trying to get to some kind of iteration here. 40. What else? 625. Okay. Okay, all yours here. I'm gonna make this an X over here because I want to solve. You guys talk to me. How do we solve for X? Yes. No?
You wouldn't have to have found a calculator by any chance. Okay, -6.
Oh, ouch. Yeah, no, I didn't see it. Man, interesting. Anybody?
Figured it out.
Yeah, thank you. No, I didn't see it though. Yeah, we can't do X root. There's kind of no such thing as having a variable as a root index. Yeah, no, good. You guys guess. Absolutely. This is what school is. Thinking about it, processing. I'll say this here. We have an X that is stuck in the exponent.
Oh, it's something, but I don't know how to do that.
I'm thinking this, guys. Do you guys remember something called log? Log here, because that's exactly what these things are for. When you have a log, when you have an exponent, when you have your variable stuck in the exponent. And 3.3 can I just make this into a 0.75? That okay? Just going to a little easier for us. And then this little guy gets to go out in front right here. So you guys on your calculators, can you do this here? Can you punch in log of 0.316406625 divided by a log of 0.75? Just want to see what happens. See again?
Can I use my calculator on my phone to do that?
Yeah, if you have a log button on there, yeah. Just want to see what happens. So log of 0.316406625. It's gonna be a little bit off because we're rounding that little piece there, right?
4.
Okay, it does give you.
Mine's day 4.
Why do you do 4 also?
Well, because we rounded, so approximately.
What in the world? It won't let me press log.
I'm sorry.
When I press log, it just says error.
No, so what you got to do on that one, you got to do 0.316406625 and then press the log, and it'll give you the value of it. You got to write that down as opposed to holding it in memory. Okay, are we good there? It's still 4, any which way we slice it. That's cool. Okay, so now we got 4 here. What we're trying to get is n-1, is that right? In there, so n-1 is equal to 4, therefore n is equal to 5. We got going to 5?
-4.499757.
Yeah, that's what it gave me.
It's because you didn't divide by log base or log 0.75.
Sorry, want to do it on the calculator, guys, or what? Are we good? Okay. All right, I'm going to go from i's 1 to 5, and my first value is 32. And what, 3/4 or 0.75? Maybe 0.75 a little easier than 3/4. And this would be an n-1 formula, 32. Fifth over making it just a little nicer would be 1 minus 0.75, so 0.25 then at that point. All right, punching in the calculator, what do you guys get? See if you guys can punch all that in as one piece.
97.625.
97 point?
Wait, what was the last file? Did you go back and I want to skip it?
Or not 0.1625, just 96.625.
96
97.625.
without the 1. Come on, 1 erase, go away. Sorry, for 96 or 97? 97?
Yeah, 97.625.
Okay, so see you guys get that on the calculator here. No, it should have been, the answer should have been 4.
I got 40.
40, okay. Probably do you hit a 7.5 as opposed to a 0.75?
Maybe.
That's because you'd be off by 10. Okay, easier that way?
Or maybe I put 4.9 instead of 0.499.
Yeah, you're off by a decimal place.
So
Okay, Luke, are we good there? 97? Jamming. Okay, let's go with the next one here. How about infinite? That was a finite. We'll jam with an infinite geometric sequence. How fun is that? Let's begin. So first things first, here's what I want to do. I want to go from I is equal to 1, and I'm going to go to infinity. That's super cool. I have a sub 1, and put your thinking caps on. This is what I have. Is that right? Formula would still be a sub 1, and it would be 1 minus r to the n over r. N is infinity. Crazy. So here's a little problem here. If the r value is greater than 1, this thing's going to become bigger and bigger and bigger forever, right? Because you're actually multiplying things that are bigger than 1. So say you're multiplying by 2. That means you're doubling each time, double, 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 right? So the only time we actually can have a sum for a geometric sequence that actually goes on forever is if we have this condition, you guys, right here. So the r value has to be less than 1, or else there is no sum. It just goes off to positive infinity. If you are going to have a sum, r has to be less than 1. So let's think about this here for a little bit. On your calculators. So let's go 0.9. That's less than 1, is that right? 0.9? All right, 0.9. I want to take that to the second power. What you guys get? 0.81. Okay. Take a 0.9 taken to the 20th power.
Point what? 0.9 to the 20th power?
Yeah.
0.12157665546.
Okay. 0.9 taken to the 200th power. Ooh, you minus 10. Okay, so hold on. Say that again, Noah. Point. Minus 10. E minus 10. Okay, on your calculators, if you guys see this little guy here, e to the minus 10, this means how many decimal places. If it's left, it's a minus, it's to the left. If it's positive, to the right. So in this case, it's this guy, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what we have if we take this guy to the 200th power. We're good. So that's kind of weird. So then real quick here, this little piece, if I take this guy to infinity and I keep on raising it, and that r value is less than 1, where is this all going to go to? See, maybe I'm not saying it correctly. If this guy's less than 1, and we take powers of something that's less than 1, we even got a big number here, 0.9. But notice after 200 units, how small is it? Basically 0. Absolutely. So here it is. We're going to go like this. So a sub 1, and here's our formula for it. So it's going to be 1 minus 0 over 1 minus r, and eventually the formula is just like this. No, actually, no, even easier. Why multiply stuff when you don't have to? It's a multiplication by 1, right? So it's just a sub 1 over 1 minus r. There's your final formula. That's even easier than the finite formula. A sub 1 over 1 minus r. Okay, got 3 minutes to do 2 problems. What example are we on? 8. Find the sum of this guy. So again, the only time that you can do it is if I'll use n as my multiplier now. All yours there, the easy one. So the only thing you gotta be careful for, if you're going off to infinity, the ratio has to be less than 1. So 0.6, does that work?
Yes.
Yes, let's plug it into formula. Formula is a whole bunch easier. All yours, go. So it'll be a 4 on top, but 1 minus 0.6 on the bottom. It would be 40. Done. Ain't that interesting? 40? I don't think it's 10. I'm gonna go with 10. Is that okay? Because you got the 4 and the 4 will cancel themselves out. Just check it though.
Oh, yeah, I don't know what I did.
No, no problem. Okay, a little bit more difficult one. How about this? I'm gonna go with 3 plus 0.3 plus 0.03 plus 0.003 0.0003 on forever. Ah, almost 1/3. I have this little 3 1/3. Yeah, you can see it. It's going to be 3 1/3. Let's see. You can also see it as what? 3 times 3 is 9. That's 10. 10/3, right? You can see it as 10/3 as well. Let's do it by this little iteration here. So what would be the formula? Or actually, yeah, we can actually just go into, isn't 3 the first term? And it's 1 minus, what's my ratio? Ooh, that's the fun thing. What's the ratio? What gets me from here to here? 0.1, is that right? If you want to, you could just take this one, divided by that one.
1.9, so it's like 3.
Punching this in the calculator, it gets you approximately 3.33333 repeating.
It would be like 3 1/3, right?
3 1/3. And done, right at on the second. All right, guys, enjoy the rest of your Monday and enjoy senior projects for people that are going. Oh, gosh, yeah, 9.1 right at the corner desk.